This video is on adding and subtracting radicals. So there's one main requirement for adding and subtracting radicals, and that is that the number on the shelf, the index it's called, and the stuff inside have to match. So this is the index it's called, and the inside number is actually called the radicand. So shelf number and inside number must match. I need to highlight that because that is the main mistake people make, is that they don't have the same shelf number and the inside number. They have to match or you can't add them together. So for example, in this first one, it's got a cube root, right? A 3 for an index. Those are the same. And then if you notice inside, there's a 5 and a 5. Those are the same. So we can add them together. And to add them together, you just combine the outside numbers. So you add or subtract the outside numbers only. What do I mean by outside? Well, out in front. So there's a 6 out in front of that radical. There's nothing written here, though. Dun, dun, here comes the superhero 1 and says, oh, wait, I'm here. I'll step in. He's always there. So all this really is 1 plus 6, which is 7, and then you put that cube root of 5 next to it. So you're only adding and subtracting these numbers that are outside, and that's only if you have the same number up on the shelf and the same number on the inside. And then you just add those numbers out in front. If you look at this next one, it's the same indexes, right? But these are not the same. So at first you would say, oh, well, I can't add them. But sometimes you may have to simplify or break out of jail first. So let's try that. Let's see, cube root of 32. Do our little factor tree, right? Go through all our steps that we've been doing. Okay, 32 is 5 2s. Looking for a party of 3 right here. Group of 3. Looks like I've got one group of 3 2s right there, which means 1 makes it out. And then I've got a little 3 still here, and I've got 2 times 2, or 4, left over. So I am going to rewrite this. That's going to equal 2 cubed root of 4, cube root with a 3 out in front, 4 right there, and then minus 5 cube root of 4. That's this guy. Now they match. Now they have the same number on the inside and the same index, so we can add them together. Now, what do we add together, though? We're going to take this cubed root of 4, that's the thing that they have in common, and I've got 2 here minus 5 there. So I'm going to go 2 minus 5, which is negative 3. 2 minus 5, negative 3, and then we're going to throw that little cube root of 4, and that would be your answer. So 2 minus 5, and then you put the cube root back on there. So sometimes you have to simplify first. If they don't match, that's the first thing that you try and do. Make sure the numbers out on the shelf match. If the stuff underneath doesn't match, then try breaking out a jail and see if it makes a match. All right, more examples. Okay, I'm checking. I've got a 4 here and a 4 here. Check. Those are okay. 10 here and a 10 here. Check. Those are okay. So I'm going to add them together. How many do I have here? Well, there's nothing written, so we assume it to be a 1. That means I've got 1 plus 7, which is 8. And then you put the root back in, 4th root of 10. Okay, this one right here, I've got 2 and 2 underneath. I've got a 3 here. Oh, I have nothing written there. That's actually a 2 when there's nothing written, but either way, they don't match. So these ones you cannot simplify, cannot add. All right, this one, cube root of 54 minus cube root of 2. They don't match. The indexes are good, but the numbers underneath don't match. So we're going to try breaking this guy down and seeing if something will come out so that they do match. All right, so now we're at, whoops, cube root of 2 times 3 times 3 times 3. Looks like we got a pair, or sorry, a group, because our group size is 3, right? Group of 3, party of 3. Okay, one makes it out, everybody else dies, and we're left with poor old 2 on the inside. All right, so this problem is now 3 cube root of 2, that's this guy, and then minus cubed root of 2, that's this guy. Right, they match, same number on the shelf, same number on the inside. Now we just need to combine them. There are 3 here, minus 1 there, which is 2, and then we put our cubed root of 2 down. So nothing on the inside changes when you combine them together. It stays exactly the same. The only thing that changes is when you're on the outside and you combine those numbers only. Okay, these don't match, well, their indexes match, right? These are the same. Technically it's 2, but having nothing there would be the same as matching. So we're going to break them down. Let's see, 48, 3 and 16. Keep going there. Looks like 48 is actually, that's square root, because there's no number. So we're looking for party of 2, because it's square root. There's one party of 2, another. Multiply those together, and I'm left with square root of 3 still in jail. So 4 square root of 3 is 48. Now let's look at this guy. Break him down. Oh, he got up and moved. Did you see that? 9, 3, and 3. So it's 3, 3, 3. Don't forget the 2 that's outside. Square root, so we're looking for a party of 2. 1 makes it out. 1 dies. Still have 1 3 left in jail, and that 2 outside to getaway driver, right? He's multiplies by the 3 that got out. All right, so back to our problem. This equals, now that we've simplified everything, 4 square root of 3 was this guy right here, and then it's plus this guy 6 square root of 3. Then when we combine those together, now that they match, same number on the shelf, same number inside, so all we got to do is combine the number parts on the outside. So it's 4 plus 6, which is 10 square roots of 3. That's it. Okay, stepping it up a little bit. Now we've got 3 things in there. Doesn't matter. They still have to have the number on the shelf the same, and the number on the inside has to be the same as well. So if you look at this one, all of them don't have a number on the shelf, so we assume it to be a 2, right? So they're all the same. Then if you look inside, we've got a 5 here, a 6 here, and a 6 here. So this guy doesn't match. So he's going to stay exactly as is. Does not change. These other two, though, they both have a 6 and a 6. So we can combine their numbers. 5 minus 3, which is 2, square root of 6. And then we just write that next to that one that we could not combine together. And that would be your answer because you can't combine them anymore. Okay, this next one, 3 terms again. Make sure all their indexes, the shelf numbers match. We're good. They're all square roots. Technically, they're all 2. But the numbers underneath don't match. So we're going to go through and reduce each one of those to see if we can make them match. So 28, 14, 2 and 7. So it's actually 2, 2 and 7. So 2 squared is 7. And then don't forget this 2 out front. So this one is actually 4 square root of 7. Now this middle one right here, he's already reduced, right? He's already squared a 7. So I'm just going to bring him down. Okay, then we'll talk about this guy. 63, that's 3 and 21. 3 and 7. So it's actually 3 times 3 times 7. Oh, look, we got a pair of homies. 3 made it out. 7 left over, which makes it plus, because it was plus up here, 18 square root of 7. Now, there's 3 of them, and they all match. So we're just going to take all 3 outside numbers and combine those together. So I've got a 4 here. Whoops. Got a 4 minus 1 plus 18. Boop, boop, boop. Calculator says that is 21. And then you put the square root of 7 back on there. Done. Again, this one's got 4 terms this time. Still the same thing. You're trying to make sure that the numbers on the shelf match, and then make sure that the numbers underneath match. So let's see if 8 breaks down. Yep, 2 and 4, 2 and 2. So 3 2s, pair of homies. There's also this 2. That's a lot of 2s. That's too many 2s. That's too many. Look at it, 2s. But that was my sound. No. What's that thing called? It's a tambourine? No. The thingies. Whatever. Sorry. Sidetrack. Let's see. 254. Let's break this down. Alright. Looks like we've got, on the outside, inside 2, 2, 3, 3, 3. So we've got homies. 1 out, 1 dead. 1 out, 1 dead. And left over is a 3. And then don't forget getaway driver. So this one's going to be 12 square roots of 3.